In today's video, we will be solving questions 13, 14, 15, 16, and 17 from the new syllabus Mathematics Book 2, 7th edition, Chapter 2, Exercise 2F. Now, the statement of the question is 6 adults and 4 senior citizens have to pay $228 while 13 adults and 7 senior citizens have to pay $459 to visit an exhibition at the Art Science Museum. Now find the total amount 2 adults and a senior citizen have to pay to visit the exhibition. As we don't know the total amount paid by 2 adults and a senior citizen, so let the amount paid by an adult is X dollars and the amount paid by a senior citizen is Y dollar. It is stated in the question that $228 is paid by 6 adults and 4 senior citizens to visit the exhibition. So we can write the equation 6x plus 4y equals $228. Additionally, $459 is paid by 13 adults and 7 senior citizens. Therefore, we can write the equation 13x plus 7y equals $459. As you can see, a system of linear equations is obtained. You can solve this system either by the elimination method or by the substitution method. I'm going to solve this system of linear equations by the elimination method. Therefore, I'm going to multiply equation 1 by 7 and equation 2 by 4. Now, the question arises, why are we multiplying these equations by 7 and 4? Well, the answer to the question is that the coefficients of the variables in both equations are not the same. In the first equation, the coefficients of the variables x and y are 6 and 4, while the coefficients of the variables in equation 2 are 13 and 7. To make any one of the coefficients the same, I'll multiply these equations by 7 and 4. So, to multiply equation 1 by 7, we get 7 into 6x plus 4y, which is the left-hand side of equation 1, equals 7 into 228, which is the right-hand side of equation 1. We get 7 times 6, 42x, and 7 times 4, 28y equals 7 times 228, 1596. I'll label this equation, this new equation, as equation 3. Now, I'll multiply equation 2 by 4. So, left-hand side of this equation, 13x plus 7y, will be multiplied by 4. Also, right-hand side, 459 will be multiplied by 4. We get 52x plus 28y equals 1836. And I will label this equation as equation 4. As you can see, we have the same coefficients for the variable y in both the equations, equation 3 and equation 4. The coefficient of the variable y is 28 in these two equations. So I'm subtracting equation 3 from equation 4 to eliminate the variable y in these two equations. Therefore, left-hand side of equation 4, which is 52x plus 28y, negative sign left-hand side of equation 3, which is 42x plus 28y, equals 1836, negative sign 1596. Now these are the right-hand sides of these two equations. Next step is to multiply this negative sign by positive 42x and positive 28y. We get 52x, positive 28y, negative times positive 42x is negative 42x, Negative times positive 28y is negative 28y. On the right side, subtracting 1596 from 1836, we get 240. As you can see, positive 28y and negative 28y is 0, and positive 52x negative 42x is 10x equals 240. Since we are finding the value of x, so I'm going to divide this equation by 10. We get x equals 24. To find the value of the variable y, I'll substitute x equals 24 into equation 3. Our equation 3, 42x plus 28y equals 1596, becomes 42 into 24, which is the value of x, plus 28y equals 1596. Now, 42 times 24 is 1008 plus 28y equals 1596. I'm going to solve this equation for y. So first I want to eliminate this 1008 from the left side. So I will subtract 1008 from both sides of this equation. We get 28y equals 588, which is the difference between 1596 and 1008. We are finding the value of y. The next step is to divide this equation by 28. We get y equals 21. Now that we have found the values of the variables x and y, which means we have found the amount paid by an adult and the amount paid by a senior citizen, right? So therefore the amount paid by an adult is x dollar, and x dollar is 24, and the total amount paid by two adults is 24 times 2 equals $48. And therefore the amount paid by a senior citizen, which we have assumed as y, is $21. So the total amount paid by two adults and a senior citizen is $48 plus $21 equal $69. Question number 14. Lixin intends to buy either gift A, which costs $10, or gift B, which costs $8, as Christmas gifts for each of her parents, 2 siblings, 13 relatives, and 10 friends. Given that she intends to spend $230, find the number of each gifts she should buy. 3 important points that need to be discussed before solving this question. First, the cost of gift A is $10 and the cost of gift B is $8. The second point is the number of parents, siblings, relatives, and friends, which is 27. The third point is the amount Lixin intends to spend, which is $230. So, to find the number of each gift she should buy within the amount of $230, let the number of gift A be X and the number of gift B be Y. Since the cost of gift A is $10 and the cost of gift B is $8, the total amount she wants to spend is $230. Therefore, we can write the equation 10x plus 8y equals 230. Additionally, the total number of parents, siblings, relatives, and friends is 27. So we can write the equation x plus y equals 27, which means the sum of gifts A and B is 27. I label these two equations as equation 1 and equation 2. As you can see, it's a system of linear equations which can be solved either by the elimination method or by the substitution method. Let's solve this system of linear equations by the elimination method. First, I'll multiply equation 2 by 10 to make the coefficients of the variable x in both equations the same, because we want to eliminate the variable x. So, if I multiply equation 2 by 10, we get 10x plus 10y equals 10 times 27, 270. I'll label this new equation as equation 3, And now I will subtract equation 3 from equation 1. 10x positive 10y, negative sign 10x positive 8y equals 270, negative sign 230. Now, next step is to simplify the parenthesis. I will multiply this negative sign by the first term positive 10x and then by the second term positive 8y. We get 10x plus 10y, negative 10x, because negative times positive 10x is negative 10x, and negative times positive 8y is negative 8y. On the right side, if we subtract 230 from 270, we get 40. As you can see, positive 10x, negative 10x is 0. We get 10y, negative 8y, and their difference is 2y equals 40. Since we are solving this equation for y, so we need to divide both sides of the equation by 2. We get y equals 20. Now, to find x, I'll substitute y equals 20 in equation 3. Equation 3, which is 10x plus 10y equals 270, becomes 10x plus 10 into 20, which is the value of y, equals 270. 10 times 20 is 200. We are solving this equation for x, so I'll subtract 200 from both sides to eliminate positive 200 from the left side of the equation. We get 10x equals 270, negative 200. Now, difference between 200 and 270 is 70. To find the value of x, I will divide both sides by 10. We get x equals 7. Now that we have found the values of the variables x and y, which means we have found the number of gifts Lixin intends to buy. Therefore, number of gifts A Lixin should buy, which we assumed as x, is 7. And therefore, number of gifts B Lixin should buy, which we assumed y, is 20. You can also verify the solution by substituting the values of the variables x and y into equation 1 and equation 2. So, equation 1, which is 10x plus 8y equals 230. If we substitute x as 7 and y as 20 in this equation, we get 10 into 7 plus 8 into 20 equals 230. 10 times 7 is 70, and 8 times 20 is 160. 70 plus 160 is 230, which is the total amount Lixin intends to spend. Now, equation 2, which is x plus y equals 27. If we substitute x equals 7 and y equals 20 in this equation, we get 7 plus 20 equals 27. 27 is the total number of people to whom Lixin intended to buy gifts. Question number 15. There are some chickens and goats on a farm. Given that the animals have a total of 50 heads and 140 legs, how many more chickens than goats are there? 50 heads and 140 legs. That sounds interesting. Anyhow, we need to find out how many more chickens there are than goats. Let's take the number of chickens as x and the number of goats as y. Following the statement of the question, it looks like a funny question, but let's proceed. As mentioned in the question, the animals have a total of 50 heads. So, our first equation becomes x plus y equals 50. Furthermore, the animals have a total of 140 legs. So, our second equation becomes 2x plus 4y equals 140. I am taking 2x to represent the number of legs for chickens and 4y to represent the number of legs for goats. Sounds funny, doesn't it? Okay, I'll label these equations as equation 1 and equation 2. A system of linear equations is formed. So we can solve this system by the elimination method or by the substitution method. I am solving this system by the substitution method. So from equation 1, which is x plus y equals 50, to solve this equation for x, we get x equals 50 negative y. Let's name this equation as equation 3. And let's substitute equation 3 into equation 2. Equation 2, which is 2x plus 4y equals 140, becomes 2 into 50 negative y plus 4y equals 140. Next, I'm going to multiply 2 by positive 50 and the same 2 by negative y. Now 2 times 50 is 100 and 2 times negative y is negative 2y plus 4y equals 140. 100 negative 2y positive 4y is 2y equals 140. We are solving this equation for the variable y. Therefore, I'll subtract 100 from both sides of the equation. We get 2y equals 40. Now, it's time to divide this equation 2y equals 40 by 2. We get y equals 20. Now, to find x, we need to substitute y equals 20 into equation 3. Equation 3, x equals 50 negative y becomes x equals 50 negative 20. 50 negative 20 is 30. Finding the values of the variables x and y means that we have found the number of chickens and the number of goats. Therefore, the number of chickens, which we assumed x, is 30, and the number of goats, which we assumed as y, is 20. The question is to find the number of more chickens than goats. This can be calculated by subtracting 20 from 30, and the difference is 10, which means there are 10 more chickens than goats. Question number 16. $80 is divided between Ethan and Michael such that 1/4 of Ethan's share is equal to 1/6 of Michael's share. How much does each of them receive? Now that we are familiar with how to solve these types of questions, I'll assume Ethan's share as x dollars and Michael's share as y dollars. Since $80 is divided among Ethan and Michael, we can write the equation as x plus y equals 80. Additionally, 1/4 of Ethan's share is equal to 1/6 of Michael's share. Therefore, we can write the equation 1/4 of Ethan's share, which is x, equals 1/6 of Michael's share, which is y. I'll label these two equations as equation 1 and 2, and I will solve this system of linear equations using the substitution method. So, from equation 1, which is x plus y equals 80, to solve this equation for x, we get x equals 80 negative y. Let's label this equation as equation 3. And let's substitute equation 3 into equation 2. Equation 2, 1 upon 4x equals 1 upon 6y becomes 1 upon 4 into 80 negative y equals 1 upon 6y. If we multiply 1 upon 4 by 80, we get 1 upon 4 into 80. And if we multiply 1 upon 4 by negative y, we get negative 1 upon 4y equals 1 upon 6y. To eliminate 1 upon 6y from the right side, I'll subtract 1 upon 6y on both sides of this equation. But before this, if we divide 80 by 4, we get 20. Negative 1 upon 4y, negative 1 upon 6y equals 0. We are solving this equation for the variable y. So, I want to eliminate positive 20 from the left side. So, I'll subtract 20 from both sides of this equation. we get negative 1 upon 4y, negative 1 upon 6y equals negative 20. It's time to take the LCM of the fractions negative 1 upon 4y, negative 1 upon 6y. The LCM of 4 and 6 is 12. You can also find their LCM by making the denominators the same. But I want to share this method with you guys. In this method, I'll find the LCM of 4 and 6, which is 12. Next, I'll divide the LCM 12 by the first denominator 4, which gives us 3. I'll multiply 3 by the first numerator, negative 1y, which gives us negative 3y. Again, I will divide LCM 12 by the second denominator 6, which gives us 2. And I multiply this 2 by negative 1y, which gives us negative 2y equals negative 20. Negative 3y, negative 2y is negative 5y. Since we are solving this equation for the variable y, so I'll multiply both sides of the equation by 12. We get negative 5y equals 12 times 20 equals a negative 240. Next step is to divide both sides of the equation by negative 5. We get y equals 48. Now to find x, let's substitute y equals 48 into equation 3. Equation 3, x equals 80 negative y becomes x equals 80 negative 48 equals 32. Finding the values of the variables x and y means that we have found the shares of Ethan and Michael. Therefore, Ethan's share, which we have assumed as x, is $32, and Michael's share, which we assumed as y, is $48. You can also verify the solution by putting or substituting the values of the variables x and y into equation 1 and 2. Equation 1, x dollars plus y dollars equals 80 becomes $32 plus $48 equals $80. Equation 2, which is 1/4 of x equals 1/6 of y. If we substitute x as 32 and y as 48 in this equation, we get 4 times 8 32 and 6 times 8 48, which means that 1/4 of Ethan's share is equal to 1/6 of Michael's share. Question number 17. Rui Feng deposited a total of $25,000 in Bank A and Bank B at the beginning of 2013. Bank A and Bank B pay simple interest at the rates of 0.6% and 0.65% per annum, respectively. He withdrew all his money from the two banks at the end of 2013. If the amount of interest he earned from each bank is the same, find the amount of money he deposited in each bank. In the beginning of the question, I will assume the amount deposited to Bank A as x dollars and the amount deposited to Bank B as y dollars. According to the statement, Rui Feng deposited a total of $25,000 in Bank A and Bank B. So our first equation becomes x plus y equals 25,000. Equation x plus y equals $25,000 shows the sum of the amount deposited in Bank A and Bank B. As for the second equation, the statement is as follows. Bank A and Bank B pay simple interest at rates of 0.6% and 0.65% per annum respectively. As both the interests are paid in equal intervals of time, that is, in a year, we can write the equation as 0.6x equals 0.65y. Let's label these equations as equation 1 and equation 2, and I will solve the system of linear equations by the substitution method. So from equation 2, which is 0.6x or 0.60x equals 0.65y. If we write this decimal number 0.60 as a fraction, we get 60 upon 100x equals 65 upon 100y. If we multiply both sides by 100, we get 60x equals 60y. I'm solving this equation for x, so let's divide both sides by 60. We get x equals 13 upon 12y. Divide 65 and 60 by 5 because they are the multiples of 5. Now let's name this new equation as equation 3, and let's substitute equation 3 into equation 1, which is x plus y equals 25,000. So what is x? It's 13 upon 12y plus y, or we can also write this y in the form of fraction like y upon 1 equals 25,000. Now if we take the LCM of 12 and 1, which is 12, and step 1 is to divide this LCM by the first denominator 12, which gives us 1, and next step is to multiply this quotient 1 by the first numerator 13y. We get 13y. Again, I'm going to multiply LCM 12 by the second denominator 1, which gives us 12, and if you multiply the quotient 12 by the second numerator y, we get 12y equals $25,000 or 25,000. It's time to multiply both sides by 12 because we are simplifying this equation for the variable y. We get 25y upon 12 equals 25,000. 25 is the sum of 12 and 13. So let's multiply both sides by 12. We get 25y equals 12 times 25,000. And now I will divide both sides by 25 because I'm solving this equation for the variable y. We get y equals 12 times 1000. Let me simplify this for you. That is 25 times 1, 25, and so we get 12 times 1000. So y equals 12,000. Now substitute y equals 12,000, sorry, 12,000 into equation 3. So equation 3 is x equals 13 upon 12y. I'm going to replace y by 12,000. So we get 13 times 1000 equals 13,000. Now we have found the values of the variables x and y, which means the amount deposited to bank A, which we assumed as x, is 13,000, and the amount deposited to bank B, which we assumed as y, is 12,000. You can also verify the statement by using the sum of x and y, which is, equals 25,000 as equation 1. If you calculate 0.6% of 13,000 and compare it to 0.65% of 12,000, you will see that they are equal, which verifies the second condition or equation.